Greetings to respected Madam, Sir. My name is Pavan Sai. I'm a second year student of CSE AIML from Section C. So this presentation is focused on data structures. The topic is edge coloring of graphs with applications in coding theory. So let's get into it. So edge coloring is a critical concept in a graph theory, especially for optimizing resources allocations in various applications. The presentation explores the fundamentals, principles of edge coloring, its different types, and its significant implications in coding theory. By understanding these concepts, we use enhance error detection, correct data transmission, and improve network design effectively. The edge coloring fundamentals. So edges and converting of a graph is understanding the relationship and the correct connectivity between nodes in a graph. Applications, how graph converts are used in real life scenarios like networks, social media, and optimization problems. So encoding theory is a technique for representing data in data efficiently and accurately includes errors, error detection, and correction methods. Definitions and concepts. Edge coloring involves in assigning colors to edges of the graphs. So the edges colors do not share the same color. The minimum number of colors required for such a coloring, it is known for the graph. Sorry, it is known as the graph chromatic index. Exploring properties such as bipartite graph and Weising's theorem helps estimate the theory foundation of this mathematical construction. So types of edge coloring. There are several types of edge coloring, including a proper edge coloring, perfect matching, and total coloring. Each type has specific applications and constraints. Proper edge coloring ensures no two adjacent edges share a color, while perfect matches efficiently pair edges without conflicts, and understanding these types in a crucial for their application in coding the theory and practical implements. So the properties and the theorem. Key properties of edge coloring includes the chromatic index, which determines the multiple number of colors need for a proper edge coloring. So important theorems such as Weising's theorem helps classify graphs into categories based on their chromatic indices. Understanding these properties is vital for applications edge coloring in practical scenarios and analyzing graph behavior efficiently. Weising theorem is a result in a graph theory that concerns edge coloring of a graph. For a simple graph with a maximum degree, the chromatic index minimum number of colors needed to be colored the edge so that no two adjacent edges share the same color is either delta or delta plus 1. The chromatic index minimum number of colors required to color edges without conflict. So maximum degree, the largest number of edges in distance to any vertex. Every graph falls into the either class 1 where x equals to delta or the class 2 x equals to delta plus 1. So consider a triangle graph which have 3 vertices and 3 edges. Maximum degree is 2 and the chromatic indices are 3 where we get delta plus 1 which is a class 2. The application scheduling problems, assigning the slots or the resources with conflicts, network link assignments, ensuring adjacent connections don't interfere. The frequency assignment in communication networks. So applications in coding theory. So error detection and corrections. Edge coloring is a edge coloring plays a crucial role in coding theory by facilitating error detections and corrections. By assigning different colors to edges representing data packets, system can identify conflicts and errors during transmission. This enhances reliability in data communication and ensure accurate data return, uh, retrievals in various applications, including telecommunication and computer networks. So error detections uses a code like parity bits or checksums. Um, these checksums and parity bits are used to detect errors in transmission data. Graphs can model connections to design error checking schemes and error code correction. Coloring like hammering color or Reed-Solomon codes, they help uh, they help to correct errors with retransmission. Graph structures can represent relation between bit for correcting errors. Efficient data and transmission. Graph theory helps in designing networks for minimal interference and maximum reliability. Optimization in encoding. Graphs algorithms can minimize the number of bits which are needed or optimized code length. Examples using a bipartite graph, model bit uh, positions and a parity check in Hamming codes. Network designing implications. In network designing, edge coloring aids in optimizing resource allocation and improves efficiency by minimizing conflicts and ensuring maximum utilization of paths. Networks can achieve seamless data flow, effective edge coloring strategies, enhancing performance metric such as throughputing latency, crucial for designing robust scalable and network systems. So the effective data flows, proper network design ensures smooth and faster communication between nodes. Error management, um, graph-based modeling helps in error detection, correction and fault tolerance. Resource optimization helps in allocate the bandwidth channels and storage efficiency. Scalability, well-designed networks can handle growth in users, devices or data without performance loss. The security and reliability, graph structures helps in identifying vulnerability and design secure pathway. The coding scheme integrations. Integrating edge coloring with various coding schemes fosters, improves data integrity and the security techniques such as using distinctive colors of edge for different coding algorithms. This enables better error management and adaptation to network conditions. This integration unlimitedly leads to more resilient communication framework capacity of handling diverse data types and volumes. And conclusion. In conclusion, edge coloring of graph is a service. Uh, Edge coloring of graphs serves as a fundamental concept which significant implications in various fields, particularly coding theory, and understanding its properties, types, and applications can be enhanced error management, optimized networks, designs, and integrated diverse coding effectively. As data communications are about to evolve, the leveraging edges of coloring strategies will be paramount for the reliable and efficient systems. Thank you.